Hello friends and welcome to YouTube channel Freedom Tech, and in this session what we are going to learn. In this session we are going to learn how we can use Autodistill for automate labeling process for YOLO. So before we move to our practical friends, if you learn something from our videos, please consider to subscribe our channel. Okay friends, thank you so much and let's get started. So friends, as I mentioned, today I'm going to share with you how we can use Autodistill for automate the labeling process for YOLOv8. So let's get started. For that, the basic thing, first we are going to install our basic packages. So just open Thony Python IDE, then go to the tools, manage packages and search for opencv-python. Hit enter, first package, click on install button and it will install opencv-python. Then we need Ultralytics packages. So Ultralytics, hit enter, just click on Ultralytics, click on install button, that's it, it will install Ultralytics. Then we need a CVZone package, search for CVZone package, first package, click on install button and that's it, it will install our CVZone on our Windows 11 machine. So friends, we have done with package installation. Now we need our repository. So for today's session I have created a new repository. I will mention the link inside description box. You need to simply copy paste the link inside the browser. Then our repository name is automate labeling. So go to the code, click on download zip and it will download our zip format repository. As you can see, we have successfully downloaded our repository. Just go to the folder, downloads and right click to the repository, WinRAR, extract as a folder name. It will extract our folder automate labeling -main, again same folder. And first we need our video file. So vid.txt, just open as a text file, copy the link, mega cloud link and open the new tab and just press Ctrl+V and hit enter. It will open our video link for downloading purpose. So this is what our video file, just click on download and it will download our video file. So friends, as you can see, we successfully download our video file. So minimize all these things and then go to the downloads and this is what our video file. Right click and just cut and move the video file inside our same repository automate labeling -main, just paste it. Now let's just start our video file. And as you can see friends, there is a construction side and we have workers, or we can say we have engineers which is work on the site, and our goal is to detect a safety helmet. So as you know, if we want to detect a custom object, so of course for that we need to create a labeling process. So for that we use a label img software. So here we are going to use basically Autodistill for automate the labeling process. So our goal is to detect helmet using Autodistill. Simple. So this is what our video file, as you can see, this is what our video file, that's it. Now first we need images from the video file itself. So for that we have img.py code which basically use our video file and it will create the images from video file. So for that, first inside same repository we are going to create a new folder, create the new folder and mention the name images. That's it, images, it's a is single, okay. So images, this is what our folder, and now just open img.py and here we need to mention our video file name which is helmet.avi. So helmet.avi in cap is equal to cv2.video capture. So helmet.avi, and then this is basically maximum frames, means this is the number of images which we want for this particular project. So 50 images is enough. You can simply increase the number. If you want to go with 150, you can mention 150. If you want to go 50, you can simply mention 50. So as I mentioned, for 50 images is more than enough for this particular project. And here we want to mention cv2.im, right? Here we want to mention our folder where we want to save our images. So just open the repository where we create a new folder called images, right click to the folder and then copy as a path. It will copy the path and then open TonyPython ID, and then from images, here from images remove all the things. From images just remove it. So here go back and press Ctrl+V. It will copy paste our new folder path, and then just remove this code like this way and the add slash like this way, and then here img, here we want to mention the image name. So here I will go with only img. So the img is basically the image name, and it will save all the images inside images folder where we create our folder inside our repository. And here just remove this double quote, and here also. Okay, now it's good. And here we want to mention a recursive, so r. Now it will save 50 images from our video file, and it will save inside our folder automate labeling main, and then again same folder, and then we create our folder where we want to save our images, which is the images folder, and our image name is img. That's it. So just save it and run the code. As you can see, it started our video files. So when 50 images completed, it will automatically close the video file. Now if you open the images folder, as you can see, we have 50 images from our video file. Simple. So now these images we are going to move on our Google Colab machine. So we have done with our images process. Now simply we are going to open our Google Colab machine. So let me open my Google Colab. So friends, as you can see, I have opened my Google Colab. You have to open simply your Google Colab machine. Now just click on upload, click on browse, and just go to the repository and just open autolabel.ipynb. This is what our Colab file. Just click on open. So friends, as you can see, we successfully upload our Colab file. Now just go to the runtime, change runtime type, and here we want to select Python 3 and T4 GPU. Just click on save and then click on connect. That's it friends. As you can see, we successfully connect our GPU. Now we are going to run our cell one by one. So let's just start with first cell. Done. Now we are going to create images folder and dataset folder. Just run the second cell, and now if you just click on this folder icon, as you can see, we have empty folder, the images folder and dataset folder. So we want to move our images which we create with the help of video file inside this images folder. Simple. So just click here for images, just click on this images folder, 3 dots, then just click on, select the first option which is upload. As you can see, click on upload. It will open our local browser. As you can see, it will open basically local folder for selecting our data. So here we want to select our images folder, and then we have all the images. So just press Ctrl+A. It will select all the images because we want all the images. So just press Ctrl+A and select all the images. Just click on open and then click on OK. Now it will upload all our 50 images inside images folder on Google Colab machine. So it's now uploading. Meanwhile, we are going to simply run our next cell. So this is what our next cell, where we are going to install some packages for this project. So Autodistill, as I mentioned, this is the main package for automate the labeling process. So Autodistill and Autodistill DETR, then grounding dino, which we are going to use for custom object detection, and then supervision and the roboflow. That's it. Now just run the cell and it will install all the packages. And we have done with images. As you can see, inside images now we have all our images. if you click on any images, so this is what our first image, as you can see, the image 0 jpg, image 1 dot jpg, simple. So we successfully upload our all the images. Now it's basically install our all the packages. So friends, as you can see, we have done with package installation process. We have completed this cell. Now just scroll down and come to the next cell. Here we want to mention the path of our images and the dataset folder. So just click on next cell, and then here we want to count how many images we have. So just click on next cell, and as you can see, we have 50 images. And then just click on next cell, then click on next cell. It will basically show all the images. Done. So as you can see here, we have all the images. That's it. Now this is the main code. This is the main code where we are going to use Autodistill for basically custom object detection, we can say. So here it is, as you can see, the base model here. This is the prompt and this is the class. So here we want to mention the class names which we want to detect. So this is basically prompt and this is the class. So first we want to mention prompt. So of course the prompt for helmet, we are going to simply mention helmet. So helmet, and the class name is also same, helmet. Done. That's it. This is the changes which we want to only mention. You have to mention the object which you want to train. So in this scenario, or we can say in this project, we want to detect the helmet. So I have mentioned helmet as a prompt and helmet as a class. Now we are ready, and just run the cell. It will take some time, and then we have our result. So friends, as you can see, our code is completed and we have done with detection. So now as you can see, the cell is completed. There is a green tick mark. So we have done with detection. So now we want to see the result. So here we want to mention where we have our all the data. So now if you go inside dataset folder, we have annotations folder, then we have images folder, and inside that we have images, and then inside the train folder again we have images, all the images as you can see, and then inside train folder we have labels for each image, and then we have valid folder, then we have images folder, and again we have images and the labels. And this is what our data.yaml file, as you can see, the class name and the train images path and validation images path. So this is what our data.yaml. So now if you just scroll, and here we have done with this cell. So just run the cell. Now this cell, it will show the result with detection. Done. Now if you scroll down, and as you can see friends, there is a result in front of you. We successfully detect the helmet from all the images. So friends, now we have done with auto labeling process. Now we need our best.pt model. So now we are going to use data.yaml file, and we are going to create our YOLOv8 custom object detection model. So just scroll down, and here this cell, as you can see, pip install Ultralytics. Now for this cell we want to again restart our session. So if I click the cell without restarting session, as you can see, there is a simple error. So we need to again restart our session. So just go to the runtime and then restart session. Just click on restart session, click on yes, and it will restart our session. As you can see, it's restarting. Done. Now just run the cell pip install Ultralytics, and it will install Ultralytics package. So we have done with pip install Ultralytics. Now here it is, as you can see, it will use our data.yaml file for content dataset from the content dataset folder, and then we have 100 epochs, then image size is 640, and it will basically use the YOLOv8 s.pt model, and then we have our own custom object detection model for detecting the helmet. So just run the cell, and friends, as you can see, it started our training process 1 out of 100, so it will take some time. Meanwhile, I will pause the video. So friends, as you can see, we have completed our training process, and model is basically saved inside runs, detect and train. So if you just go to the runs, detect, and then we have train, and then we have weights folder, and inside that we have our base.pt model. So we are going to simply cross test our model. So here, as you can see, for the next cell, it will basically use our model base.pt from runs, detect, train, weights, base.pt, and here we want to mention our image. So let's just mention the image. So from images, and let's just go with img18.jpg. So here I will mention img18.jpg, simple. And if you run the cell, it will save our result. And as you can see, it saved the result inside runs, detect and predict. So again, just make like this way, runs, and then we have detect folder, and if I just click on like this way, then we have predict folder, as you can see, and inside that we have our img, which we use img18.jpg, and as you can see, there is a result. So it means our base.pt model is perfectly working. So we use here Autodistill for making automate the labeling process, and we create our own custom object detection model for YOLOv8. Now we are going to simply download our model, and then we are going to cross check our model with full video file. So here train and weights, and then we have our base.pt model. Just click on download, and it will download our model. So friends, as you can see, we successfully download our base.pt model. So minimize all these things, open the file manager again, and then go to the downloads, and then we have our base.pt model. As you can see, right click, cut, and move the model inside our folder, again same folder, and just paste over here. So I have mentioned the full code for YOLOv8 object detection. So test2.py, but first we need to create a coco1.txt, which is the custom label file. So right click and simply create the new and text file, text document, mention the name, which is coco1.txt. just open as a text file and mention the object name, the custom object name, which is helmet. Done. Just save it, file and save. Just close it, and then open test2.py with Tony Python ID. So here it is. As you can see, I mentioned the model base.pt, then we have coco1.txt, and here we want to mention our video file name, which is helmet.mp4, and then this is what our basic code for YOLOv8 object detection purpose, which I have explained in several previous videos. Also I have created the playlist. So if you don't know how to use YOLOv8, you can simply watch my playlist. So here it is. As you can see, we have rectangle, and then the C is basically for the class name. So we are done, and let's just first go with a one by one, frame one by one. So I have just mentioned here a 0. So if I save the code, if I run the code, I think I have mentioned the wrong video file name. It's not helmet. Oh, it's helmet.avi, not mp4. The file extension avi, not mp4. So just save it, and if I run the code, and as you can see, there is a result. It's detecting helmet. Here also, this person we have it's wearing a helmet here also, and here it is also. As you can see, we can see here there is helmet also and helmet. So now simply we successfully create our own custom object detection model, making automate the labeling process with the help of Autodistill. So if I save the code, now I have start the while loop. We have now while loop with our detection, and as you can see, simple. So this is how, friends, you can use Autodistill for automating labeling process, and with the help of YOLOv8 you can create our own custom object detection model. So in this video we use Autodistill for detecting helmet. In next video also we are going to use Autodistill, and then we are going to detect some other custom object, and basically I will create the series where we are going to use Autodistill for making automate the labeling process, and we are going to detect more and more custom objects. So this is it for today's video. We'll meet our next video. Till then, thank you, take care, and bye bye.